Now for our next example, we're given with 0.300 molar solution of acetic acid and ionize this at 0.767% at 25 degrees. Now, what is the pH and what is Ka? And acetic acid is CH3COOH. So plus H2O forms equilibrium with H3O plus CH3COO minus. Now original is 0.3 molar. Now what is change? It told you the change is 0.7% because 0.767% is ionized. So we just need to do 0.3 times 0.006767, which will give you 2.3 times 10 to the negative third. Because you just multiply this number by this number, and beware of the percentage, you gotta add 2 extra zeros in there. And that tells you how much is being ionized, percent ionization. So this will give you 0.3 minus that number, will give you 0.29769. Now this is going to be 0 and 0 plus x. Now since this is minus x, the x will be 2.3 times 10 to the negative third, and x will be 2.3 times 10 to the negative third. And what is the Ka? So Ka is equal to x squared, which is 2.3 times 10 to the negative third squared, divided by 0.297699. So if we do that, we have, that will give us an answer of 1.77, which runs to 1.8. We can do 1.78 times 10 to the negative fifth. And we round it to 1.78 because we're given with 3 sig figs. And now let's calculate the pH real quick. pH is equal to negative log of this number, which will equal to negative log of 2.3 e to the negative third is 2.64. And if we're gonna keep it to 3 sig figs because we're given with 3 sig figs, we're gonna need to add an extra one with 3.8. And again, you want the number of sig figs that you want to keep should be consistent to what you're given. Now the question says, write the equilibrium expression for the ionization of HOI and calculate the concentration of HOI aqueous at equilibrium. So HOI, let's quickly make a rice chart, plus H2O forms equilibrium with H3O plus. Now another information that you're given is that concentration of H3O plus at equilibrium is equal to 2.3 times 10 to the negative fifth. And so with that information, you know this is 0, 0 plus x, and this has to equal to this, which is 2.3 times 10 to the negative fifth. Now if that is 2.3 times 10 to the negative fifth, so is this one because they're both x. Now this is also 2.3 times 10 to the negative fifth. Now what is this? So first, we can call this x, and this is minus, let's not use x for this one, let's just say plus a. This will minus a. And what is a? A is this. So this will mean equilibrium is equal to x minus a, which is 2.3 times 10 to the negative fifth. Now we can use our Ka that we're given to solve for this. Oh, sorry. And the Ka is also given, which is 2 times 10 to the negative 11th. Right, now, with these given information, 2 times 10 to the negative 11th, aka K, is equal to the products, 2.3 times 10 to the negative 5th times 2.3 times the negative 5th, which is basically square root, divided by x minus 2 minus 3, 2.3 times 10 to the negative 5th. Now, this 2.3 times 10 to the negative 5th is smaller than 1.0 times 10 to the negative 4th, so we can cross this out because it will not have a significant effect on our x. Now with this equation, we can easily find it by multiplying x on both sides and dividing this on both sides, so 2 times 10 to the negative 11. So this is saying 2.3 e to the negative 5th squared divided by 2 e to the negative 11th divided by 2.2 times e to the negative 11th, which will give you x as 26.45. So now that we found x, we know that the initial is 26.45. 26.45 minus this number, which is smaller than 0, will still give us the same thing. Now 26.45 minus this number, which is smaller than 1.0 times 10 to the negative 4, we should know that it will give us the same thing. And 26.5 minus this is indeed the same thing, which is, let's round it to the correct sig figs, which is just 26, because everything is in 2 sig figs. And that is our answer to this one. This is our equilibrium expression, and which is very sloppy right now. And this is the final equilibrium concentration for HOI. Now there is a follow-up to the question, and that is, what concentration of HCl would produce a solution with the same pH as the 0.45 molar solution of HC3H5O2? And then the answer would be, since HCl is a strong acid, right? And we need to produce something with the same pH as this 0.45 solution of HC3H5O2. And how is pH found? pH is equal to the negative log concentration of H3O plus, right? And in order to get the same pH, our concentration of HCl plus has to be the same, and the concentration of HCl plus is this. Since a strong acid like HCl will ionize completely in water, so we only need our number of H3O plus as the number of moles of HCl that we need. So the answer will be 7.1 times 10 to the negative 3 molar will be the concentration of HCl that we need. And this is because strong acids ionizes completely in water, and therefore 7.1 e to the negative third molar of HCl will result in 7.1 e to the negative 3 molar of H3O plus, which will result in the same pH. And that is it for these practice problems. Thank you for watching.